So guys, welcome to our mathematics class, which we we are going to have a lecture. So there is a difference between a lecture and a revision. So when you talk of a lecture, this is where I will normally explain the full content and what you need to know. So in this lecture, I'm just going to explain to you about another type of numbers which are just irrational numbers. So in the previous class, I talked about rational numbers, which are just numbers that can be expressed in form of a fraction, or these are numbers that can be expressed in form of p over q or a over b. So in this particular class, I'll look at irrational numbers, and it's very important for us to know the definition of irrational numbers. So please make sure that you watch the previous class where I talked about rational numbers. So when you talk of irrational numbers, these are numbers that cannot be expressed in the form of p over q. So these are numbers that cannot be expressed in the form p over q or a over b. In short, what we are just trying to say is that irrational numbers are just opposites of rational numbers. So when you talk of irrational numbers, these numbers are just the opposite of rational numbers. So if you remember very well, when we talked about the rational numbers, we had to understand that rational numbers can be expressed in the form of p over q or a over b. But when you talk of irrational numbers cannot be expressed in that form. Cannot. There is that point which I need to emphasize on. So mostly when you are talking of irrational numbers, there will be an aspect of you trying to borrow the knowledge from rational numbers. So in other words, when you say irrational numbers, these are not fraction, are not decimals, and they are not ratios. So let me write that down. They are not, one, you need to understand that they are not fractions. That's the first thing that you need to know. And then two, these numbers are not ratios. Okay, these numbers are not ratios. And lastly, these numbers are not decimals. That's why they are just opposites of what? Opposite of rational numbers. So I'll quickly go into examples. I don't know if there is any question. So please, if you have a question, you are free to ask me. So on this part, do we have any questions, ladies and gentlemen? I'll start with Philip. Do you have a question?
No.
You don't have?
Yes.
Okay. Florence, do you have any question?
No, I don't have any question.
Okay, that's amazing. Let's move on and look at the examples. So when you talk of my examples are normally focused on what you'll be examined on. My examples and most of the stuffs, they are normally focused on what you are going to be examined on. So I'll start with the first type of questions that you need to expect in your test, quiz, or the final exams. So the first one is prove that square root let's say square root 3 is an irrational number. Prove that square root 3 is an irrational number. So this is the first set of example which you need to know, and this is the first type of question that you have to expect in your test, quiz, and even in your exam. So this is how you go about this particular question. So you're going to say solution. So when you say solution there, you're going to say by contradiction. We know that irrational number are the opposite of rational number. And then the other thing that I'm going to emphasize on is when you're trying to prove, okay, in mathematics, especially irrational number and irrational number, you need to be able to communicate. You should be able to communicate. One thing that you need to understand is mathematics is a language. The same way English is a language, okay? The way I'm talking to you, the way we are able to exchange words, that's how mathematics is. It's a language, okay? Whatever I'm writing, someone who has never even been to school, they should be able to understand, okay? Even my grandma in the village, they should be able to understand when they read what I'm solving, especially when we are asked to prove. So you're going to say by contradiction, okay? That simply means that we are now contradicting this particular statement. So by contradiction, let's square root 3 be a rational number. So let's square root 3 be a rational number, such that you need to understand that a rational number is a number that can be expressed in the form of P over Q. So you're going to get square root 3 is equal to P over Q. Okay, so this is the first statement that you need to make. Okay, since we have said by contradiction, we are contradicting this statement. We are saying by contradiction, let square root 3 be a rational number. Okay. We are treating this square root 3 as a rational number. So when we treat square root 3 as a rational number, that simply means that we can express it in the form of P over Q. You can express it in the form of P over Q. So once you write this statement, this is what you need to do next. Okay, this is what you need to do next. You are simply going to say, since we have said square root 3 is equal to P over Q. Okay, so your next step is just to simply introduce the square. To get rid of this square root, you're going to say squared there and also squared there, meaning you square both sides. So when you square both sides, you're going to have 3 is equal to P squared over Q squared. P squared over Q squared. So after you do that, you can simply work on this guy by just cross multiplying. So you can just easily cross multiply. So when you cross multiply there, this will be 3Q squared is simply equal to P squared. Okay, so when you write this is your equation 1, or this is your first equation. Okay, so you say this is your first equation. So what you need to understand is, yes, you have made your first equation, but you should be able to interpret this equation. Okay, you need to interpret this equation. what does this equation mean? So this simply means that p squared is divisible by 2 or by 3, sorry. So this is a 3. So this means that p squared is divisible by 3. Okay, so you're going to make this statement. So this means that p squared is divisible by 3. So when you say is divisible, it simply means that 3 is a factor of 3, or 3 can go into p squared. Okay, that's what this statement means. So if that's the case, then this also means that p is also divisible by 3. So this also means that p is also divisible by 3. Okay, this also means that p is also divisible by 3. So when you make such a statement, then you have interpreted this information. So if you don't write this statement, then you are going to have some less marks as compared to the total marks you are supposed to score. Okay, so with that in mind, you can now think a bit and get rid of p. Okay, you can think a bit and get rid of p so that you can have equation 2. Okay, so you can say let p, okay, you can say let p be equal to 3r. You can say let p be equal to 3r. So we replace p. Okay, we replace p in equation 1 with what? With 3r. We replace p in equation 1 with what? 3r. So 3r is just a variable, or 3 and r, so r is just a variable and 3 is moving because of that. So here if we had a 2, we would have put a 2r there. I'm repeating this concept because it's very important and this is the easiest way you can master it. So if you had a 3 there, you would have put a 3. If we had a 2 there, you would have put a 2 there. What if we had a 5? Taonga, if this where there is 3 there was a 5, what are we supposed to put here?
I'm supposed to put 5r.
Correct. So that's what we are supposed to do. So in such a case, we are now going to replace using the equation, meaning since we have the first equation was 3q squared is equal to p squared. So where there is p, we are going to put 3r. So we are going to say 3q squared is equal to p. Guys, this is just p. So open bracket, you're going to say 3r and then you say squared. So with that information in mind, you can just simply work out 3q squared is simply equal to 9r squared. Okay, so after that you can divide throughout by 3, that one and that one goes, so you have q squared is equal to 3r squared. So if you look at equation 2, it's more like similar to equation 1, just that where there was p squared, there is now q squared. That's the reason why we had to interpret this information in such a way. So with this, you can now interpret what this means. So you can say this means that q squared is divisible by 3. This means that q squared is divisible by 3. And this also means that q is also divisible by 3. So this also means that q is also divisible by 3. So this is the statement that you are supposed to make. So if you look at what we made, the conclusion we made from equation 1, we said p was divisible by 3. Okay, p was divisible by 3 from the knowledge we had to use for us to interpret equation 1. So this is the same thing that has happened to q. Q has also been found to be divisible by 3. Okay, now when both p and q have the same factor, this simply means that these guys are irrational number. Okay, so that simply means that square root 3 is an irrational number, because when you talk of an irrational number, the given variables, they're not supposed to have a common factor. Okay, they're not supposed to have a common factor. So in this case, we are going to say since p and q have a common factor, okay, and this factor is 3, have a common factor, this contradict our first assumption, the assumption we made. So this contradict our assumption. This contradict our assumption because we made an assumption somewhere else. So in such a case, this square root 3 is not equal to p over q. Square root 3 is not equal to p over q, where we can even put where p, q are members of what? Of integers, where p and q are members of integers, and q is not equal to 0, because when q is 0, then that simply means that this is undefined. That's why we have put such a description. So with that in mind, we can say therefore square root 3 is an irrational number. Therefore square root 3 is an irrational number. So that's how easily you can work out this question. So my advice is, make sure that you practice this question. Make sure that you are able to solve and follow the same route that I have followed. Do we have any question on this particular example? Please, if you have a question, feel free to unmute yourself, and then I'll be able to listen to you.
Sir, I'm not able to see properly. As P and Q have a common factor 3, this contradicts the, I don't know what word it is.
Our assumption.
Sorry?
Assumption. Okay, nice. ASSUMP and then TION. Assumption. Okay, we can move. So I'm going to give my last example, which is example 2. I'm going to give my last example, which is example 2.
No, I need a brief explanation about the something that you're talking about.
Which part are you not clear?
Where you wrote square root 3, I don't know, yes, this last part that you wrote.
Square root 3 is an irrational number. Square root 3 is an irrational number.
No, I need an explanation here on top.
Which one? Square root 3 is not equal to P over Q. Where P is a member of integers, Z, it stands for integers. Z stands for integers. And Q cannot be equal to 0 because when you put 0 there, this will be undefined. This will be undefined. Defined. And the reason why we have put not equal to, it simply means this side it is rational. Sorry, this side it is irrational. Yeah, this side it is irrational. And then this side it's rational. This side is irrational and that side it is rational. That's why we know that irrational cannot be equal to rational. So that's why we have put an equal, it's not equal to. Is that okay now?
Yes, it is. All
right, we move. So the second example is another way of setting these questions. So this is whereby you are being taught, given that square root 2 is an irrational number, given that square root 2 is an irrational number, prove that square root 2 minus 3 is an irrational number, So this is also another way in which those questions are being said, and you are expected to know how to go about it. So I'll write solution. And then this is how you are going to work out. So you're going to say assuming that, you can say assuming that square roots 2 minus 3 is rational or is a rational number. Okay, is a rational number. Assuming that square root 2 minus 3 is a rational number, then then you can pick it up. You can say, since we have said is a rational number, we can say square root 2 minus 3 is equal to P over Q. Then from there, you can just simply make square root 2 a subject of the formula. So you're going to say square root 2 is simply equal to P over Q and plus 3. P over Q plus 3. So with that in mind, we can simply work out the right hand side. So we have square root 2 is equal to P over Q plus 3. So you can work out this side. So you have square root 2 is equal to common denominator is simply Q into Q1, 1 times P, it's P, and then this is over 1 into that, it's Q times that, it is 3Q. So if you look at that, from that case, you can simply tell that square root 2 is irrational. Square root 2, oh, my phone has dropped. Okay, square root 2 is irrational. So square root 2 is irrational, and then from there you can also say p plus 3q over q is rational. Okay, this one is rational, and from that you have to say rational cannot be equal to irrational. Rational number cannot be equal to irrational number. Rational number cannot be equal to rational number. So you write that. Therefore, then you can say therefore, let me just quickly change my color. Therefore, square root 2 minus 3 is irrational. So is an irrational number. Irrational number. Yeah, so that's it, and that's how easily you can work out that. Do you have any questions, ladies and gentlemen, before we call it a day? Yes, Florence, what's your question?
So what if square root 2 minus 3 we are all in the same square root?
You mean they are like that? 2 minus 3.